Example 6. What is the concentration of hydronium ion of a 0.10 molarity sodium acetate? The temperature is 298 Kelvin. Ka of acetic acid is equal to 1.8 times 10 to the negative 5. This is the summary of this problem. Let's look at the flowchart. The first step to use the flowchart is to figure out how many solutes in the solution. Sodium acetate is the only solute in the solution. The next question we need to answer is the solute an acid, a base, or a salt? Sodium acetate is a salt. Then we need to figure out what kind of salt is sodium acetate. To figure out what kind of salt is sodium acetate, we need to figure out what acid react with what base to form sodium acetate. We know that sodium acetate is a product of the reaction between acetic acid and sodium hydroxide. Acetic acid is a weak acid because the Ka is very small. Sodium hydroxide is a strong base. This is something you have to memorize. Therefore, sodium acetate is a product of the reaction between a weak acid and a strong base. The instruction says treat it as a weak base. Go to 2, which is here. Let me show you why sodium acetate can be treated as a weak base. Sodium acetate is a strong electrolyte. It will break into sodium ion and acetate ion. Acetate ion is a conjugate base of acetic acid. It will react with water to create hydroxide ion. By definition, acetate can be treated as an Arrhenius base as well. The product between Ka and Kb is equal to Kw. We know at 298 Kelvin, Kw is equal to 1.0 times 10 to the negative 14. We already know the value of Ka, of acetic acid. And the Kb of acetate is 5.56 times 10 to the negative 10. Now we can calculate the ratio between Kb and the initial concentration of the base. Then we can decide which way we should go. From our calculation, the ratio between Kb and the initial concentration of the base is smaller than 10 to the negative 3. So we can use this equation to calculate the equilibrium concentration of the hydroxide. And we also know that Kw equal to the equilibrium concentration of the hydronium ion multiply the equilibrium concentration of the hydroxide ion. At 298 Kelvin, Kw is equal to 1.0 times 10 to the negative 14. This will be our final answer. Can you follow my example to work out this problem by yourself? This information may be helpful for you to find a solution for this problem.